Okay, last time we already get through the diode and Zener diode. Okay, I want to ask you a few questions before we keep moving. Okay, for this circuitry, can you tell me what VL equals?
And Mr. Pham, this is a regular diode, correct?
Exactly. I think I need this room so I can draw it.
V out is 0.7.
You're right, but I want to know the other student. You have to telling me, so that's why. It will be telling you understand or not understand. Now one telling me to get 0.7 V out. But I want to know, you know why you get 0.7?
Hi, Professor.
Yeah.
I've been sick for a week, so I was missing like all your lecture last week. So can you explain like how to calculate the diode V out by detail? Sorry.
Okay, now again.
Okay, thank you.
You understand it's a diode? This is a symbol. And that will be anode. This is a cathode. Okay? And the voltage across the diode, we call VD, equal the voltage from A to C. VAC equal VA minus VC on the top. Okay? When you're working on the diode, if you don't know the diode on or the diode off, you cannot solving any problem. Okay? Now, the diode made by silicon diode, the voltage VD equal 0.7 volt. That only telling you if the voltage at A higher than voltage at C, 0.7 volt, that means the diode will be on. Otherwise, diode will be off. Okay? If VA higher than VC 0.7 volt, diode will be on. Otherwise, diode will be off. Now, we're talking about diode on. Okay, when you say the diode on, you have to substitute diode by the battery. You battery. .7 volt for diode.
Mr. Pham, when you say we have to substitute it for the battery, what do you mean we have to substitute it?
The thing is you cannot solve the problem. Okay? If you're still leaving the diode there, so the circuitry now will be look like. Okay? Instead the diode, you get the battery.
Oh, that's to solve, right? If there is a okay,
Substitute.
okay.
The thing is that diode in the circuitry, you cannot do anything. So you must substitute the diode by
I
the
see.
battery.
Mhm.
So now, when you measure the V out, okay, then you measure from V out to the ground. That means you measure from here to here. That telling you V out equal 0.7. The thing is when you measure the voltage across the battery, you get the battery voltage. I given you the example. You can get a car battery 12 volt. 12 volt that connect into too many things inside your vehicle. However, when you measure the voltage across your battery, you will be get the battery voltage. That means 12 volt. However, when you try to do for the diode or the Zener diode, for the diode, you have to come up with diode on or diode off. Okay, now we go back the diode. Okay, first thing, how do we know diode on or off?
Because 5 volts is more than 0.7.
That look like okay, but not complete. Who else can telling me more?
You actually want to see VA is minus VC from the formula. You want to see
VA minus VC.
You want to see VD equals VA minus VC. And then from that, you'll determine whether it's on or off.
No. That is just a diode voltage, nothing to do. My question is for that circuitry, how do we know diode on or diode off? Okay, now I'm telling you, diode on, that means they have to be greater than equal 0.7 volt. They
Right.
off. Otherwise, they off. My question is, for that circuitry, how do we know You have to prove the diode will be on. Like one student say 5 volts higher than 0.7 volt, right?
Right.
They on, but it's not correct perfectly. That's okay. Who else can tell me? Okay, if
You mean the anode is more positive than the cathode?
no, how come you know that positive more than anode?
Oh, we have to measure the voltage across.
No, not right now. We're doing analyze, not measure. Measure, that means you need to get equipment to do the job.
Right.
Right now, no. But we're working on theory. That will be applied the same for diode normally or Zener diode. Okay, I can tell it you. First thing, without diode. No diode here. Okay?
Mhm.
V out equal 5 volts.
What Vout equal
5 volts.
5 volt. Does it make sense to everyone? Y equal 5.
Because there's no current flow through R1, so you just measuring basically across the battery.
Exactly. The thing is the current flowing here. Open circuit I equal 0. I equal 0. The voltage drop across that resistor. Ohm law. V equal R1 time I. I 0. That means the voltage drop is 0. You get
Mhm.
a 5 volt here.
Mhm.
Okay, you get a 5 volt here. You drop nothing here. So that's why
Mhm.
Vout equal 5 volt. Okay, now Vout equal 5 volt. That will be telling you anode higher than ground. So that's why you say diode on.
Mhm.
Okay?
Mhm.
Now, if I change that one, okay, to 0.4 volt. Okay? The diode on or off?
Off.
Off. The thing is 0.4 volt. Without diode, you get 0.4 less than 0.7. Diode will be off. Okay. When the diode off in your circuitry, we don't care that. Now the circuitry will be look like open. They on, they connected,
Mhm.
they off, they open. That is a key point. Okay?
Mhm. Mhm.
Yeah. The make sure you understand real thing. Okay? Okay, I try to review for you. The thing is today you get a quiz asking about diode and a Zener. Now, Zener here. You see this is the difference. Right here, simple. And this will be cathode and not here. Now, we're using the Zener for keep a certain voltage. Okay? This, when we say the Zener breakdown, that means any voltage higher than Zener voltage, they set it to Zener voltage. I given you example. VG 5 volt. The thing is when you go to buy a Zener diode, they will be asking you what voltage you want. You have to tell what voltage you want so they can sell it. 5 volt, 10 volt, 15 volt, no matter whatever voltage. For example, here 5 volt. So if the apply voltage into that point here, 20 volt, then you can say, okay, Zener will be breakdown. That means they will be set this output now only be 5 volt. That is the purpose of the Zener. Okay? And when the Zener breakdown, okay, in the circuitry, they will be look like battery. Okay? Positive, negative, and that will be VG. Okay? Also, they can say the Zener diode can be working like normal. If they working like normal, that means just like regular diode. Okay? This side VA, this side VC, still 0.7 volt for silicon diode. So if you understand on that, that will be no problem for diode. Now, for this circuit, you get the VG, Zener, and the voltage Zener will be 10 volt. Okay? Fourth thing, same thing. You deal with the diode. Then Zener, is it they break it down or they not? Or they just working like normal diode? How do we know they break down or not? Who knows? Tell me.
Hey, Mr. Pham, you told us last time anytime you analyze the zener, take the zener out and then analyze the circuit without the zener.
Perfect. That means first thing you suppose no zener. Not zener here. What we out?
V out is 20.
20 volt. Okay? And 20 volt higher than
10 volt.
10 volt. So that's why zener will be
Broken.
down. Okay? So
Uh-huh.
now you can say here will be 10 volt.
Okay.
Okay? So number A, they say they ask me out. Then the answer will be 10 volt.
Uh-huh.
Okay? And now they can ask you the current through 220 ohm. That means the current flow here. Okay? So if you want to get the current I, the difference between the voltage here and the voltage here, that means equal 20 minus 10 divide to 20. Okay?
Uh-huh.
So that current flowing here, one going out, one go to zero. Okay?
Uh-huh.
If you get the resistor load outside here, okay, for example, you get RL here. I can calculate the IL equal V out divide RL, correct? V out is 10 volt. RL, whatever they give it, you get IL. If you want to calculate the IG, how? Linear current. You can say that I total. Okay. How we get the linear current? Well, now telling me.
That first current that you put up there, the 20 minus 10 over 220, that current minus the I load is
I
IG.
total. That I total, right?
Okay, yeah.
And now you can easily calculate the IL. A load
You mean the
That's all.
IG?
divide to IL.
Mhm.
And finally, I want to know that current. IG equal what?
I total minus IL is IG.
Perfect. Okay? The thing is, you guys have to be working with me, okay? I need to know, even you can say something not right, but that's the way you learn it. Try to make everything clear, okay? That's just showing you information. You can look into that, okay? LED display, they're using everywhere. This is the 7 segment. They're using everywhere, right? In your watch, in everything. They're using to display a letter, a number, okay? Turn on, turn off. It's segment in here, just a diode, okay? They can be turned on, they can be turned off. Now, this is the one you need. Rectifier. That means inside circuitry here, you get a diode. Okay? Rectify. They're telling you this is the input coming. Okay? Like you get 110 volt. This is the positive. Okay? So when they go to the diode, then you can get this signal coming out. However, for the part negative here, okay, they cannot turn on the diode. So that's why you get nothing. Okay? So basically they allow positive part to go. Okay? Not negative. So that circuitry they call a rectifier. Okay? That is a very, very basic. You must understand in order you can keep moving on. Okay? If you get any question, just bring it up. Okay? Now, this is just a general information. They get the sideway coming. Okay? Sideway coming in. They go to rectify. Okay? And you understand if they go to the rectify, the signal will be look like nothing. That only positive signal go. Okay? No negative. Okay? So they go to another circuitry they call a filter. What inside filter? Basically, just a capacitor. Okay? Just a capacitor, so you can see positive they charging up. Okay? Keep charging up. So they up to the point. In here go to 0, they get the VDC. Okay? On the top, they still get some AC. Who know the name on this signal?
Ripple,
Who can tell me what the name of this signal here on the top of the VDC?
ripple voltage.
Ripple. That's what you need to know. Ripple. Ripple means the noise.
Is that the same as AC riding on DC?
Right. When you get a contract with the government to design, so the signal coming out, they're asking for a ripple. Have to be less than 0.1 volt or 0.1 millivolt. That's just the noise. Okay, by the way, what is the noise? By basic definition,
It's an unwanted signal.
yeah, the noise, that means the signal you don't want it. That's what they call unwanted signal. Okay, and they can go to the regulator, try to clean it up. So basically, power supply coming out will be only VDC. They don't want ripple. Okay, that is the way they design the power supply. You go to buy the 5-volt power supply or 12 volt. That is the way. Okay. Now, next one, we're talking about halfway rectifier. The circuitry look like that one. Input sideways. Okay. V pick here. Now you see V out. V out. Input positive. Turn on the diode. Okay. Diode on. Okay. So when the diode on, they allow that signal go through. Okay. When you get a negative here, diode off. So that's why you get 0. And they keep going. Okay. So that's what they call a halfway rectified. Make sure you have to understand. Okay, otherwise you have to bring it up. I help you out. You must understand it. Now, however, I bring it up, few things. When the input we pick positive, the diode on or off.
It's on.
It's on. Perfect. Now, I already telling you, when the diode on, you substitute by the battery. Okay, plus minus 0.7 volt. Okay, if you not agree with me, let me know. The thing is, they lecture here, they just display in ideal. But if we want to display exactly what happened, so at the output here, okay, you can get this signal for AC. However, you also get the DC 0.7 volt. That will be a negative 0.7 volt. So if you draw correct, first thing you have to draw right here, minus 0.7 volt. Okay? And the sideway will be go this way. From here, go up. Okay? So, what a V peak? How do we know to calculate the V peak in this case? If I gave it to you 5 volt,
So you're talking about the second approximation?
the second one,
Approximation.
yeah, the real one.
7.
That means at the output you get a sine wave. However, also you have to get a diode voltage minus 0.7 volt. On the drawing here, they draw ideal diode 0 volt. They don't care. They just care about halfway, 25. However, we want to draw the real output for the circuit. So, output will be stuck at minus 0.7. Right here, going up, not this one. Okay? They going from here, go up, not from here. That's the ideal. Practical will be this way. So, my question is, what if we peak at the output? If I given you we peak in 5 volt,
So would you say it's 5 volts minus 0.7?
exactly. That's what they telling you right here. Right here. Second approximation. V peak out equal V peak in minus 0.7. That's why I explained to you how come they minus 0.7. The thing that they start from minus 0.7 going up. And you understand the V peak will be measured from where to where. V peak have to be measured from 0 to peak right here. Okay? So they going from 0 up to the top. That means you have to subtract 0.7 7. Okay, not from here to go. They must be, the peak must be from round 0 to go to the top. So that's why they say right here, V peak out equal V peak in minus 0.7. This is the key point for the rest of this lecture. If you cannot understand that, you will be get lost. Okay, so basically the answer will be V peak will be 5 minus 0.7, 4.3.
Hey, Mr. Pham, do the VN peak always start at 0?
Perfect.
Okay, it does.
They have to. Okay, next transformer. This just some formula you need to know. This what they call a transformer. Okay, transformer. Okay, primary, secondary, P primary, S secondary. Okay, now see, transform one voltage to the other. Okay, they transform one voltage to the other. They need the transformer. You understand the power outside? It can be 400 volts. However, when they go into your house, 120. The thing is they need the transformer. They just transform one voltage to the other. Primary voltage VP and the secondary voltage VS. Okay. One VP, one VS. This is the load. NP right here. Number of turns in primary and then add number of turns in secondary. That means how many wire, okay, turn of wire, okay, on the primary and on the secondary. And they get the formula NP over NS will be equal to VP over VS. From this formula, you're able to calculate the VS, that means a secondary voltage by the formula. Here. VS equal NS times NP divide to NP. Okay, like you get 120 volts at your outlet, and now you want less voltage, then you need the transformer. Okay, if NS greater than NP, will be a step-up transformer. What that mean? Step-up transformer, that means the VP 100 volt and the VS can go up to 300 volt. That will be step up Okay. If step down, that means VP 120 volt, output only 50 volt. Step down. Okay. NP less than NS less than MP. Step down. Not too much thing to memorize. Okay. But you must be understand when you read through it. Okay, now on this circuitry here, for the circuit show, they want to know the peak secondary voltage VP. You know that will be V secondary voltage. Let's see, VS secondary. So basically, on that one, need to correct V here. Second have to be VS. Okay, that is a VP. Primary, that will be VS. And now you can using the formula. Okay, VS. Okay, equal NS time and VP. Divide and the P. You don't have to memorize the formula. However, when you're looking into the book, you're able to get that formula. Even myself, I couldn't remember, but I know how to do it. So first thing, what NS equal? You know that to 1. If you're looking here, NP and S, so that will be NP. That will be NS. So basically, NS will be 1 time VP 150 divide NP 2. So that's why you can calculate the VS secondary.
Is that 156?
Yeah, you can calculate any value. I just telling, have the student, when you're looking into the circuitry, you know how to calculate it. The rectified peak output VP. That means VP, okay? Let's see. The secondary voltage, okay? Rectify. That means they want to get a V out here. Make sure they will be rectified. The thing is when they go through the diode will not allow negative. Here. No this part coming out. Only the positive go. Okay? So basically, at the V out here, the signal will be look like we already showed you. That's what they call a halfway rectifier. They rectify only positive. not negative. Okay, and also in the positive, the diode will be on. Okay, so substitute here by the battery. Plus minus 0.7 volt. And now they're asking for the input frequency 1 kilohertz. What frequency of the output? Output frequency, the same input frequency. That's what you must memorize. Okay? Any question about halfway rectifier?
And just one question, Mr. Pham, on letter B, is that supposed to be whatever you get for the halfway minus 0.7?
Yeah. That's what, if you want to calculate the V peak output, right?
Right?
You have to take the V peak input minus 0.7.
So it's output.
Right now you get 156, you have to minus 0.7.
Well, first you got to do that step up, step down thing first, right?
Yeah, it's 78 minus 0.7.
That will be step down. If you want the up or down, you looking into here. And add greater than NP. Step up.
What did B ask for? Letter B. No, letter B.
Letter B
Yeah, on the problem.
on the problem here.
Yeah. What did letter B ask for? The rectified peak output. So V peak out.
Okay, VP out. That means they want the V peak out. Same thing here.
Mm-hmm.
If you want the V peak out, not the same like V peak in here, correct?
All right.
The thing is when they going down 0.7, when you want to measure the V peak, you have to going from here, 0 up. So that's why you take the V peak in minus 0.7. You will be get the V peak out.
All right.
Okay, next one, full way, rectify. You see the picture at the output, you can see this is the input positive. They rectify. And this is the negative part here. Also, they rectify. So they rectify both positive and negative. So that's why they call it full way rectify. Okay? The other one you learn, they say halfway. That means they rectify only positive up a sideway, or they rectify only negative up the sideway. That's what they call a halfway. And now this circuitry will be rectified both positive input and negative input. Okay. Only thing is, the transformer now will be different. You can see the difference right here. In the middle here, they connect to the ground. Okay, so this transformer will be cost a lot of money. Basically, they separate transformer to two parts, one here and one down here. Okay, they will be equal value. Okay, but you get two different signals. Now, the DC average, VDC, equal Q times V peak, okay, divide to 6.284. Okay, you can see right here, they given you, this is a half here, Vs divided by Q. And right here, Vs divided by Q. From the top to the bottom here, that will be Vs, secondary voltage. However, they divide by 2. Okay, so F, that means frequency out equal Q times frequency in. In this case, they draw for ideal diode. You see that? Ideal diode. That means you can see they're not going down minus 0.7. Okay? Practical diode, VD 0.7. Okay? So that's why V peak out have to be V peak in minus 0.7. We keep repeat that for you. And this transformer, they call a center tap transformer. Okay? That cost a lot of money. So, they don't want to using the center tap. Now you will see. This is the calculation. Full way rectified. There's just a little more detail for you. Okay? You can see in here. This is the VP divide 2. V second divide 2. And remember, from here to here, that V secondary, that is primary. Okay? And basically the transformer divide secondary to two parts. And you can see on that secondary, this is the positive. And same time, at the secondary, they will be opposite. Okay? That means on the first part, they get positive, the next, on the second, in the bottom here, they get exactly the same signal. However, will be opposite. Okay? That is how the transformer working.
So,
Okay?
Mr. Pham, what's the output voltage across RL?
Okay, what the output voltage across IL? Okay, a little more you can see that will be helping you. Now, center tap transformer, okay, you can see. First thing they draw for you, input positive here, okay, and they go to the output, that will be positive. That's for this part here, okay, and now they will be get the part for the secondary. We'll see here. You see that?
Mhm.
Now they draw for this part here. Then this what you get. Okay. So basically you get the completely one cycle and the output will be look like. And this is the formula. Okay, now they get anything to try to explain to you. Only thing is, make sure later on, okay, you see it, you read it, you understand. Okay, this is a trend center tap transformer. So basically from here, okay, you get V peak second divided 2. And the same thing on the other side, minus V peak second divided 2. Okay, and go through the output of the diode. Then you can get a V peak second divided by 2 minus 0.7. The diode on. Same thing on the other side. Okay, minus 0.7. And if you want to calculate the V, okay, at the secondary, divide by 2 minus 0.7. That is the formula for you to calculate it. And here, basically, they want V peak 40. So the voltage will form across each halfway of secondary winding and across RL. That one you need to try. Okay, basically they give it to you here. 25 volt. Okay, and basically the input here, the output not 25. The thing is they have to be minus 0.7. So that's why you get 24.3. So basically 25 minus 0.7. Otherwise, later on when you're looking into the circuitry, you see 24.3 volt and you don't know why. The thing is diode on, they get minus 0.7. Okay, that next one. Same thing. If we're looking at the output working exactly full way rectified. That means they rectify positive, rectify negative, doing both. So that means they're working exactly what we just get through it. However, the difference will be, this must be cheaper. They just using 4 diode. Okay, with a regular transformer, not a center tap. Center tap cost too much. So that's why they design this circuitry. Most in the power supply, they're using this circuitry. Okay, so basically you can get a red diode, okay, and the blue one. Okay, so when you get the signal positive here, so if I said maybe, let's see what normally they're using. Okay, D1, D2, D3, D4. D1, D2, D3, D4. Okay, so when you apply the input positive, which diode on and which diode off? That means when you get a positive right here. Okay, tell me which diode on.
There's
Which one?
there's two diodes on at a time.
Yeah, tell me which one, D1, D2, D3, D4.
Okay, 50-50, D1 and D2.
Okay, now diode on will be D1 and D2. We have to prove it. When you get a positive here, so the diode D1, the other side connect to the ground. So D1 must be on. Okay. So you understand when you get the positive D1 on, what else will be on?
D2, they work together.
How?
Okay, so let's see, D2, plus minus plus.
Remember, one side positive, the other side negative. So
Okay, so D1, I know it's D1 and D2, but I'm having a hard time explaining it.
okay. I tell
Is
you.
it because we are both negatives?
Right, the thing is
Yes,
this
sir.
side have to be negative, this side positive. Positive here, this side negative. Now, positive and this D1 connect to the ground, so that's why D1 off. D2, one side connect to the ground. Right here, 0 volt, right?
Right.
And the other side negative. So that's why D2 on.
Oh, yeah, because 0 is counted as a higher voltage than the negative side.
Perfect.
So that therefore D2 anode is 0, but it's considered more positive than the cathode.
Correct. So the first positive you get D1 on, D2 on. The second one here. So diode will be D3 and D4.
D3 and 4, if D1 and 2 is on, then D3 and D4 is off.
Right. Okay. Now when you get the negative. So basically you get the negative on the other side. On this side here. Then this side will be opposite. They will be positive. Okay, so if you get a negative on this side and down here, D3 must be on. Okay, and when you get a positive here, and this D4 connect to the ground, and D4 will be on. That only thing when you're looking into the center bridge rectifier, you have to know which pair of diode will be on. And the other diode will be off. Okay? And the output coming out exactly full wave rectifier. And this just a more detail to explain to you, okay, how the current flow, how you get that positive. And that will be how you get a negative signal going by what way. Okay, your guy can read through it. I already go with you. Okay, so this is bridge rectifier, practical diode. Okay, that means now you have to adding voltage drop for the diode 0.7. So that's what they're telling you in here. Okay, only the difference will be include diode drop. On the other one, they don't care. Diode drop 0. Okay, and this is the formula. If you want to calculate the output, I don't want you to have to memorize the formula. However, when you open your notebook, you're able to get the formula. Okay, and that's just a bridge rectifier. Okay, whatever they're telling you, you can read it. Okay, now a little more explain to you. Capacitor input filter. So basically you get a sine wave. Okay, when they charging on the capacitor here, voltage keep going up. Okay, and the output must be minus 0.7. Okay, just a voltage. You see that? They will be going up, then they discharge, then keep charging. Okay, so basically they charging, okay, then they discharge and they charging, okay, and depend on capacitor and the frequency signal. So the charge and the discharge will be different. They try to make the output here to be DC voltage. That's just more detail, and we don't care about, the voltage to calculate or whatever here. We not go to too much detail. And now, input the V peak up to here. However, this is a VDC, and this is a ripple. And a ripple, again, just the noise. We want it as small as possible. Okay, and this is the example. Okay, if you can see signal coming out here, full wave, okay, and a capacitor here, we try to charge it. Okay. Okay, any question? anything. Okay. The next meeting, we're talking about bipolar transistor. Okay. Any question? Anything? If it's not, now we'll be running the quiz. You get 24 hours to upload it.
Hi, Professor.
Yes.
Before doing like the quiz,
Uh-huh.
to me it's like uh, as I told you before, I don't have a computer at home, so so last Monday I've been sick, so I did not meet you on the lab. So can you like allow me like to meet you on next Monday to take the computer home and do the quiz later?
Oh, you're talking about you want the computer, right?
Yeah. Just I've been
Okay,
sick like
Sunday
this,
you
so
see me
yeah.
up there.
So can you can I meet you like on next Monday?
Yeah, the Monday coming.
Okay, thank you.
The thing is, last Monday I get something really busy. I cannot move it. Okay.
Okay, so I will retake the quiz like
That's
when I
okay.
have the computer.
Right.
Okay, thank you.
Only thing is, if you don't want to learn, forget it. However, if you really want to learn, by anyway, we can help you.
Okay, thank you, Professor. Thank you
Yeah.
so much.
Uh-huh.
Okay, go ahead.
Okay. Now we can start. Okay.
I'm sorry to interrupt, but I just want to make sure. I know this is quiz 3. Are we making? Are we taking the quiz 2 with the 3 or?
Can you repeat the question?
So the questions that we see in the screen right now is quiz 3 diodes, and we're taking quiz 2 right now, right? Or are we taking quiz 3?
That doesn't matter.
Oh, okay. Just asking.
Maybe I make a mistake on the number,
Oh, okay, okay. I
but
was just trying to make sure.
yeah, we want after we get through the electronic regarding
Uh-huh.
to diode, that's what we will be doing.
Oh, okay. Thank you.
Okay, that will be done.
Thank you.
Any question? Anything else?
We'll be sending it as a quiz 02 report for Chuan Lee.
We number 2.
Yes.
That is number 2.
Okay. Thank you.
Okay, so
Do we have time till tomorrow or no for the quiz? To
I
submit
give
it?
you 24 hours.
Okay, good. Thank you.
I try to upload it video tonight.
Okay. Thank you,
Okay.
please.
So, good night, everyone. Okay.
You too, Mr. Pham.
Good
Thank you.
night.
Bye bye.
Good night, everyone.
Good night.
Good night.
Bye.
Good night.
Bye bye.